Part 6, Solving Problems Involving Objects. In this section, we are working with composite objects. These are shapes or parts of shapes put together in various ways to make a structure. To determine the volume of a composite object, identify the distinct objects, calculate the volume of each object, and then add the volumes. Okay, that's not so bad. Okay, so an example of a composite object is shown, okay, off here. So this looks like kind of a grain bin. Okay, so the main part of this grain bin is a cylinder. So this part's the cylinder. Okay, and then the roof, of course, is the cone. Okay, so given the right dimensions, or all the dimensions, we can figure out the volumes and put them together. Okay, so example 1 does just that. Determine the volume of this composite object to the nearest tenth of a cubic centimeter. Okay, so we can see that we have the volume. So we need the volume of a cylinder and the volume of the hemisphere. Okay, so volume of the cylinder. Okay, remember, that's on your formula sheet. The volume of a cylinder is pi r squared h. Okay, so the radius here is 18, so pi times 18 squared, and the height is 32. Okay, so the volume of this cylinder is 32,572.0 centimeters cubed. Okay, so let's just double check that. But so pi times 18 squared times 32. So 32,572.0326324. So of course there's all those other decimals there. Don't worry, we'll make sure we use them all in the end. Okay, so the volume of the hemisphere. Okay, so remember the volume of a normal sphere is 4/3 pi r cubed. So the hemisphere is 2/3 pi r cubed. So 2/3 times pi times 18 cubed. Okay, so when we type that in, that works out to 12,214.5 centimeters cubed. Okay, so then to get the volume total, we just add the two together. So 32,572.0 ... So basically the ... is reminding us that we have to use all the decimals. Okay, and then when we do that, it works out to 44,786.5 centimeters cubed. Fantastic. So not too bad. Okay, we just figured out the entire volume. All right. To calculate the surface area of a composite object, the first step is to determine the faces that comprise the surface area. Then calculate the sum of the area of all these faces. You may have to adjust some of the formulas on your formula sheet if the base of one of the objects is covered up by another. Okay, so example 2, determine the surface area of a composite object. Okay, so the surface area of this object, the wording of this question implies that the floor is included. So what we've got going on here is we have a cube, 5 by 5 by 5, okay, and then we have the triangular roof, which is going to be 4 triangles. Well, okay, the surface area, okay, of the cube. Okay, so let's start with that, and you know what, we have to figure out the area of one face. So area of the squares are 5 by 5, length times width, so it's 25 meters squared. Now the thing is, on a normal cube, there are 6 faces. The thing here is this top face isn't included because it's being covered up by the roof. Okay, so I don't have to worry about that. So I really only have a cube with 5 faces. So the area of the cube part, the surface area of the cube, is really only 5 times 25 meters squared. okay, instead of the normal 6. Now, hopefully that makes sense as to why you're doing that, because, well, it's kind of a big deal. Okay, so anyways, 5 times 25, of course, is 125 meters squared. Okay, great. Now the triangles. Okay, so the area of the triangles, so that's 1/2 base times height. And oh, look, they even gave us the slant height. We can be mean and give you just the height here, and then you'd have to figure out the slant height, but we didn't do that to you this time. So it's 1/2 times 5 meters times 4 meters. Okay, so the area of one triangle is 10 meters squared. And of course, there's 4 of those triangles. So there is 40 meters squared based on all 4 triangles. So the entire surface area, the surface area total, is 125 plus 40, so that is 165 meters squared. Okay, so we had to do a little bit of thinking, especially with the cube one, because the top face of that cube is not included in the surface area. Okay, so let's have a look at B. Okay, determine the surface area of this composite object to the nearest square foot. Okay, again, the wording of this implies that the floor is included. Okay, so let's see. The surface area of a cylinder. Okay. Okay, so that's on your formula sheet. Okay, and it is pi r squared 2 pi r squared h. Okay, so that's the lateral surface area of the cylinder. Okay, I guess we should put that lateral. Wow, can maybe read that. So that's lateral cylinder. Okay, so that's fine. 2 pi r h. So let's see. 2 pi. The radius is 2, and the height is 4. Okay, so that works out to 50.3 square feet. Okay, then we have the area of the floor, which is just a circle, so that's pi r squared. So that is pi times 2 squared. Okay, well that is 12.6 square feet. Okay, then we have to have the area of the hemisphere on top. Okay, not a big deal. So that thing, remember, we don't have to include this circle. That circle is being covered up by the 2 shapes. So the thing is, remember, the lateral surface area of a hemisphere is only 2 circles worth. So the area of the hemisphere is 2 pi r squared. Okay, it's the surface area of a whole sphere, remember, is 4 pi r squared, so we divide that by 2 to get the 2 pi r squared, but we don't have to add on that extra circle. Okay, so 2 pi times 2 squared, so the lateral surface area of the hemisphere is 25.1 square feet. Okay, and then the surface area total just adds all those up. And let's see, to the nearest square foot was 88 square feet. So that, of course, is 50.3 plus 12.6 plus 25.1. And to the nearest foot, we get 88. Awesome. Okay, example 3, solving a problem related to a composite object. So a tool shed is formed by a rectangular prism with a triangular prism as its roof. To save money, the shed will have a dirt floor. Okay, determine the surface area of the tool shed to the nearest square foot. Okay, so the idea for this, because we have a dirt floor, we do not include the area of the base. Okay, we're not building that. It's not figuring into the cost of our shed. Okay, so we have to figure out the area of the, let's see, we have a front and a back. So those are the same things. So we have an area of the front and back. Okay, so that is 2 times, let's see, the length times the width. So it's 4 feet wide and 5 feet tall. So 4 times 5. Okay, and it's 2 because there's the front and the back. So 4 times 5 is 20. So each one of these guys is 20, and there's 2 of them, so that, of course, makes 40 square feet. Awesome. Okay, now the 2 sides. The 2 sides are these ones. Okay, so they are 6 feet long, 5 feet tall. So the area of the sides equals, okay, there's 2 of those again. Okay, and it's 6 feet wide by 5 feet tall. Okay, so 6 by 5 is 30 times 2 is 60 square feet for that one. Okay, so that's the sides. Now, we also have to include the area of the triangular prism up top. So look, the triangular prism has 2 triangles front and back. So the area of the triangles, remember the area of a triangle is 1/2 base times height. Okay, so we have 1/2. The base of this triangle is 4, and the height of the triangle is 3. Okay, so 1/2 times 4 times 3. Well, that works out to, so 6 cubic or square feet, so 6 feet squared. Okay, but that's only for one triangle, so we have to times that by 2, so that's 12 square feet for both triangles. So there's the front and back, the sides, the triangles of the roof. Now we need the rectangular portions of the roof. Oh boy, that poses us a little bit more of a challenge. The reason it does is because the rectangle needs this side. We know that it's 6 feet long, but we don't know this distance yet. But we do know that this is 3 tall, and we know that this part is 2, because of course the whole part there is 4, right? Okay, so that part's 2, so again we use Pythagorean theorem. So 2 squared plus 3 squared equals, I don't know, let's just call that h for the hypotenuse squared. So 2 squared is 4, 3 squared is 9, 4 and 9 makes 13. So then h equals root 13, which is about 3.6. Okay, anyways, that's all good. So we have 2 rectangles, so area of the rectangles of the roof is, we have 2 of them again, so I might as well put the 2 in, I forgot that with the triangle. So 2 of those rectangles, and the one side is root 13, and the other side is 6. The reason I put the root 13 up there is then I don't have to worry about the ANS button for the 3.6. But it's fine, you can do either one you want. So 2 sides times root 13, okay, times 6. Okay, so that works out to 43.3 square feet. Okay, so those are all the individual parts. So now we just add up all the circles together. So the surface area total, okay, so 40 square feet plus 60 square feet plus 12 square feet plus 43.3 square feet. So the surface area total works out to 155 square feet. So I know that was tricky. There was a lot of stuff there. None of it was particularly hard. We just had to do a little bit of thinking. Not a problem. Okay, so I need you to practice this section. It's 1.7 in your textbook, starting on page 59. There's just 3 questions, not a big deal. Okay, make sure you show your teacher when you're done. Okay, so let's talk about what happens now, because this is the last video. Yay! Okay, so you have a formative assessment for Chapter 1. Then you'll have the curriculum review for Chapter 1. Then you will have the Unit 3 exam, which covers Chapters 2 and 1, so measurement and trig. Okay, So after that exam, you are completely done the course. So you still have your final exam. Okay. Now, your teacher has a final review package for you that covers the whole course. Okay, and then of course your final exam. So they will schedule or let you know when you're going to write your final, but you have to finish all the chapter 1 work, okay, your unit 3 exam, and then you have to get ready for your final. So you have a whole bunch of assessments coming up. Good luck. You'll do great. Just work hard. Make sure that you practice. If there's something that you don't get, feel free to walk back through the videos and give it a try. Your teachers are also there to support you. Okay, so good luck on everything. Way to go, guys. You're done this part of the course, and we'll see you later. Thanks.